This is 5.2, day 2, solving systems using substitution. So we've done chart and the elimination method. This is the third method, substitution. This is on page 203 in your textbook if you want to follow along. So to solve with substitution, you must solve one of the variables in terms of the other. So solve for y equals or x equals, and then substitute that in to the second equation and solve for the other variable. For example, let's solve x plus y equals 8 for y. So get y by itself. Well, how do you do that? You subtract x from both sides. And you get y equals negative x plus 8. So solving for y, which I just did, you get y equals negative x plus 8. I'm going to substitute in y equals negative x plus 8 into this second equation. I'm going to put what y equals here, and I'm going to solve for x. So x plus 2 times this y equals negative x plus 8. So I'm plugging in y into the second equation, x plus 2y equals 10. And now I have all of this equation in terms of x only. I have only one variable. So I have to distribute x plus negative 2x, and 2 times 8 is 16, equals 10. Combining like terms, I get negative x plus 6 equals 10. Right? Negative x plus 6, plus 16, I'm sorry, plus 16 equals 10. Negative x, combining these two terms, plus 16 equals 10. I'm going to subtract 16 from both sides. Then I have negative x, don't lose that negative, equals negative 6. Well, you can't solve for negative x, so I'm going to multiply by negative 1 on both sides, and I get x equals positive 6. So x is 6. So now I'm going to put that x equaling 6, x plus y equals 8, and put in positive 6 into this first equation. So I know y has to equal 2. So x is 6, y equals 2. So now I'm going to get x equals 6 and y equals 2. I substituted in to this equation, and I got it solved for y. Now I'm going to check, does it make sense? That x is 6 and y equals 2, I'm going to check. So x plus y equals 8. Well, I know it's going to work in that one. 6 plus 2 equals 8. Yes, there's my first check. X plus 2y equals 10. So plugging in 6 plus 2 times that 2, which is 4. 6 plus 4 does equal 10. So I checked it in both equations. Yes, it makes sense. That is the correct answer. Let's try this example together. So example 1, 3x minus y equals 19 and y equals x minus 4. Well, this one's already solved for a y alone. It's in the slope-intercept form and it's in function form, so I can just plug this value for y here. That's what I'm going to do. I'm going to substitute in what y equals. So 3x minus, notice, be careful, y, which is x minus 4, equals 19. So the original equation was 3x minus y. So 3x minus, this is y, x minus 4. So I have to distribute this negative. Be careful here. So 3x minus x plus 4 equals 19. 3x minus x, that's 2x, plus 4 equals 19. Subtracting 4. Oh, this is supposed to be 18. This is supposed to be 18. I think on your papers I fixed this, but I might not have. This is supposed to be 18. It's typed wrong, so let's make sure we have an 18 here. And 18 take away 4, so 2x equals 14. So if it's not correct on your papers, please make sure it's 3x minus y equals 18. It was typed incorrectly. And dividing by 2, x equals 7. So I'm going to plug in x equals 7 into this second equation, the original equation, x minus 4. So 7 take away 4. I know my y equals 3. So when x equals 7, y equals 3, that is the solution to both of these equations. So I'm going to check. So 3x minus y, does it equal 18? That's supposed to be 18. So 3 times 7, which is 21, take away 3, y is 3. 3 times 7 is 21, take away 3, is it 18? Yes, that is a correct solution. And the other equation is y equals x minus 4. So y is 3. 3 equals 7 minus 4, which is true. 3 equals 3, also true. So I checked it in both equations. And so the solution is x equals 7, y equals 3, or I could write it as the ordered pair 7, 3. Example 2. 3p's plus 2q's equals 4, and 3p's minus 5q's equals 1/2. I gotta solve one of these for p or q. If I subtract 2 q's here, I get 3p's equals negative 2 q's plus 4. I'm not going to solve this just for a p because I have a 3p right here. So I can put this expression, negative 2q plus 4, into this equation for 3p's because that's what 3p's also represents, negative 2q's plus 4. So I'm not going to divide everything by 3 and solve just for p because I see that this is a 3p. They're the same. So I'm going to plug into this second equation, negative 2q's plus 4 for that 3p minus 5q's equals 1/2. A very nice equation here. So I get negative 7q's plus 4 equals 1/2. Subtracting 4, I get negative 7q's is equal to 1/2 minus 4 is negative 3.5. Dividing by negative 7, well, negative 3.5 is half of negative 7, so q equals half. A negative divided by a negative is a positive, so q is 1/2. So substituting in 3p plus 2q equals 4 to solve, I know what q is, I got to figure out what p is. So 3p's plus 2 times 1/2 is what I believe q is, equals 4. Well, 2/2 is a whole, that's 1, so if I subtract 1 from both sides, these cancel. Then I get 3p equals 3, dividing by 3, I get p is 1. Well, hopefully I haven't made any integer or computational errors, so I'm going to check p and q in the second equation here. Here's a check. 3p minus 5q equals 1/2. I believe p is 1, so 3 times 1 minus 5, and q is 1/2, equals 1/2. Well, 3 times 1 is 3. Negative 5 times 1/2 is negative 2.5. 3 minus 2.5 is 1/2. Okay, so it works in that equation. just to be sure, I should check the first equation, 3p's plus 2q's equals 4. Well, p is 1, q is a half. Does it equal 4? 3 times 1 is 3, 2 times a half is 1, so 3 plus 1 is 4. Yes, it does work in the original one. So or in the first equation. So p equals 1 and q equals 1/2 is the solution to this system of equations. P equals 1 and q equals 1/2. Example 3, 2x plus y equals 5. Y equals 4x minus 7. So I'm going to plug this expression in for this y, because this equation is solved for y. This one's not too bad. So 2x plus what I think y is, 4x minus 7. The second equation is solved for y, equals 5. Put my like terms together. 6x minus 7 equals 5. Adding 7, I get 6x is 12. Dividing by 6, I get x equals 2. So x is 2. Y equals 4x minus 7. So now I'm going to solve for y. 4 times 2 is 8 minus 7. So y equals 1. I believe the solution is x equals 2, y equals 1. I'm going to leave this check in both equations for you to do. So pause the video for a moment. Check that x equals 2 and y equals 1 is the correct solution. And the last one, example 4, 4x plus 3y equals 23. 5x plus y equals 15. Well, this one's almost solved for y. I'm going to solve this second equation for y. I don't have to divide by anything to get rid of the coefficients. And it's not already a 3y, so that's not going to help me. So I am going to subtract 5x from both sides in this second equation here to get one of the equations solved for either y equals or x equals. And it just so happens the examples that we've done today, we've solved mostly for y. Not always the case, though. So y equals negative 5x plus 5. I'm going to put that expression into this equation for y. So I'm substituting in what y equals. And it's got a coefficient of 3 in front of it. So yes, I'm going to have to distribute here. So 4x plus 3 times the quantity negative 5x plus 15 equals 23. Distributing, I get 4x minus 15x plus 45 equals 23. So I get negative 11x, combining terms correctly, plus 45 equals 23. Subtracting 45, negative 11x equals negative 22. Dividing by negative 11 on both sides, x equals 2. X is 2. So 5x plus y equals 15. I'm going to solve this for y because I know what x is. 5 times 2 plus y equals 15. Well, 5 times 2 is 10. 10 plus 5, so y is 5. X is 2, y is 5. Again, I'm going to leave the checks for you to finish. Pause the video, finish it. Check it in both original equations. And we will practice some more substitution in class tomorrow.